1 minute.
Number one has some key wordings. I want to highlight those for you. It says sugar dissolves in water at a rate proportional to the amount still undissolved. Sugar dissolves in water at a rate, so here's the really key stuff, at a rate proportional to the amount still undissolved. So in other words, sugar dissolves at a rate proportional to the amount of sugar that's still in there, that's like, you can still see that sugar. Does that make sense? So this actually is spelling out a differential equation. You see the word rate. I'm going to use S to stand for the amount of sugar. I would say that this differential equation would be ds dt is equal to K times S. From a differential equation perspective, ds dt would be the rate of change of the amount of sugar that's still floating around in there versus the amount that's dissolved. And that is proportional to the amount of sugar that's still floating around in there, right? So when there's more sugar, the rate's going to be different than when there's less sugar, still undissolved. You guys okay with the letter K in there? Constant of proportionality? Yes? No? Maybe so?
K for constant.
Okay. K, K, right? Yeah. Okay. So then there's a number of just different ways this could go. If you watched the intro video, you saw me develop this. But the truth is that this differential equation has a solution, something along the lines of S equals C e to the kt. You definitely, absolutely need to know how to go from that differential equation to that solution curve. And I'm going to suggest that if you don't know how to do that, watch the intro video. We'll do some stuff actually sort of like that today. But you want to know either by process or by memorization, either way at this point, that's the solution to that differential equation. So then from there, we need to know what the C is, and we need to know what the K is. If you know what this is, you know this is exponential growth. If you know what this is, you can actually identify the C immediately. Anybody know what the C is? 50, yeah. So C is the initial amount of whatever it is. In this case, it's sugar. And you are told that the initial amount of sugar is 50 grams. But you know what? Maybe you didn't know that. Here's how you could get there. You could use the initial condition of when t equals 0, S equals 50, and you could solve for it. So you could say 50 is equal to C e to the 0, K times 0. K times 0 is 0, and e to the 0 is 1, so 50 equals C, right? You could do it that way. So S is equal to 50 e to the kt. Does anybody have any idea how we could then figure out what the K is? Not yet.
Plug in.
Got to plug in first. Yep, the 3 and the 20. Okay, after 3 minutes, only 20 grams are left. So let's see here, it'd be 20 for S equals 50 e to the 3k. That's another initial condition that'll help us find K. You divide both sides by 50, you get 0.4 equals e to the 3k. How are we supposed to solve that sort of thing? Yeah, we've got to do ln to both sides. So this gives me natural log of 0.4 equals 3k. Therefore, my k is whatever ln of 0.4 divided by 3 is. That's the exact number. Let's do a quick decimal approximation. You guys figure that out?
I can't read my own handwriting.
It's a problem. So one word of caution here. As you do this ln of 0.4 divided by 3, make sure that whatever you get for that k value, make sure you store it in your calculator, because if you round off like this and then you use that number, the rounded off number subsequently, you'll be off by a lot. Did you guys hear me? This will be a point of frustration for you if you use a rounded off number on an intermediate step. So make sure you store the whole thing in your calculator. So then we finally end up with this lovely S equals 50 e to the negative 0.305 t. And now finally, after all that effort, we're allowed to try to answer their question, which was right here highlighted in a lovely yellow. What is the total time it takes for 90% of the sugar to dissolve? So this is where the wording gets a little bit weird, right? So we clearly have to plug something in for S. What should I plug in for S? So I'm hearing two different answers, 45 or 5.
Definitely not.
This is 90 has to dissolve.
50 minus 45, which is 5.
Are we plugging in
The
like
key isn't the key to remember what S stands for?
it's not
It's the remaining.
Yeah, S stands for the amount of sugar that remains that hasn't been dissolved yet. So if 90% has dissolved, what percent is undissolved? Or what percentage is undissolved? Sorry. 10%, which is 5 grams of sugar. So we would put a 5 in there. So I'll try to differentiate my 5 from my S. So 5 equals 50 e to the negative 0.305 t. And then you're just into your equation solving mode here. You divide both sides by 50, you get 0.1. Did it strike anybody that 0.1 is 10%? Right? So 10% remains. 50 divided by, or 5 divided by the original would give you 10%. So then you do natural log of both sides, where you get this natural log of 0.1 equals negative 0.305 t. You do some division. Is it really that 7 number?
Yeah.
So t equals, say it again, 7 point what?
5,
3 decimals?
3, 8, or 5,
3, 9? 539? Okay. Minutes. You guys okay with that number? 7.539 minutes? Okay. Very good. Hey, can I point out something that you may or may not notice? These questions, like from a testing perspective, do you guys see how most of this is pre-calc? So here's something that sometimes people don't expect. I want to make sure that you guys are able to connect these two equations together. You definitely need to know that that is a differential equation for exponential growth or decay, and that solution curve is the solution curve for exponential growth or decay, and be able to connect the two together. That makes sense? And there might be times when you need to show the steps to get from point A to point B. Most of the rest of it is just an application using some pre-calc kind of thinking. Okay, let's do one more just for practice. If you guys would try that number 2. The one about radioactive decay. Practice working on this. Practice pushing the buttons on the calculator. Getting things written down. Ready, set, go. It is right here. Let's move ahead. We're going to do some differential equation stuff today. And I do hope that you either have this in a pretty good place, or you watch the intro video, and hopefully that helped you get to a pretty good place. Intro video is right here. Did a handful of examples. And finally we arrive at number 4. Okay, so I thought what I would do with number 4 is I would kind of work this one with you, point out some important features, how you would even score points on a quiz or a test if I had a question like this. I'll have you guys do number 5, and then we'll look at a contextual one in number 6. We'll kind of see where we're at that point. So I want to just get some basic thoughts from you, and you may or may not know the answers to these questions. The instructions up here, let's go back to the instructions real quick. The instructions say, find the particular solution to the differential equation, based on the initial condition. So guys, I want to ask you a question. If I told you that such and such, whatever it was the solution to an equation, blah, 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 is a solution to this equation, what does that mean? Johnny?
It's a certain point along the line. Equation.
That's too vague. I'm not sure what line we're talking about.
I guess in this case, it would be a certain point along the line of y equals. I would say the original function.
I would say that it's not a point. In fact, we're going to find that the solution to a differential equation is actually a whole different equation, not necessarily just a point. Although, depending on if it's piecewise, that maybe could be the case, but it's going to be a whole separate equation. But I'm not even asking about for calculus. I mean, because haven't you, think about this, guys. In Algebra 1, didn't you find solutions? In Algebra 2, didn't you find solutions to things? So in math, like when something is a solution to an equation, what does that even mean? Like that might be something good to know.
It makes it true,
Makes what true?
the equation.
Makes the original equation true. That's it, right? Makes the original equation true. So what we're going to do here is we're going to try to be coming up with some solution curve that, if plugged in appropriately, would make the original equation true. Fair enough? So here are your steps. Step 1. If the differential equation is separable, we're going to try to separate the variables. Here would be my steps here. dy dx equals positive 5xy. Veterans, at this point, how many points have I earned?
Wait, 0.
I've earned nothing. I haven't done anything yet. Do you see how there's x's and y's on each side?
You gotta separate the big.
I got to separate the variables. So to do that, I would divide both sides by y, and I would multiply both sides by dx. We do need to separate the variables. The one caveat here, the thing you got to know is, in the process of separating the variables, the dy and the dx need to be a numerator. They can't be a denominator. They need to be up in the numerator. At this point, I multiplied both sides by dx. I divided both sides by y. Veterans, again, how many points have I earned now? I have earned exactly 1 point. Okay, so on a typical differential equation solution type question, I've separated the variables, that's 1 point. Okay. Once I've separated the variables, the next step is let's get rid of those differentials by doing some antiderivatives. Yep, let's make them integrands. So I'm going to integrate both sides. On the right side, it's a straight up power rule, so it'd be 5/2 x squared plus c. On the left side, what is it? ln, let's be really careful, it's natural log of absolute value of y. Do not lose those absolute values. They may be a big deal later. Well, they kind of are regardless, but it might be a real big deal.
You have to add another C, right? Because the one we covered.
So Brandon just asked a good question. Essentially, like, why is there a C on the right side but not on the left side? Right? So technically there is a C on both sides, but if you take the C on the left side and you subtract it over to the right side, if you take some unknown constant minus some other unknown constant, what do you get?
Constant.
Some other unknown constant, none of which we know what they are, so we just call them C. So it's customary to put it on the right side, although if you decided to put it on the left side, it should work out great. It really should. Okay, so it's at this point, if you want, wanted to plug in your initial condition to find your C, you can do it right now. I personally like to do it right now, so I'm going to plug those in. I know that based on this, that when x is -2, y is 1, so it's going to be natural log, the absolute value of 1 is just 1, equals 5/2 times -2 squared plus c. At this stage, veterans, those of you that have done a lot of these, any ideas on how many points I've earned now?
You went down.
You actually lost a lot.
Now I'm down to 0. So it depends on whether this is a 4 or a 5 point question, kind of. It does. So once I've separated the variables, that's definitely 1 point. This right here, this question or this step is kind of the questionable step as far as how many points I would have earned. It's either going to be 1 or 2, depending on if they gave you credit for each side. So we'll put 1 or 2 potentially, depending on how difficult those integrands are to handle. And then at this point, I have definitely earned another point because I included a plus C and I've shown evidence that I plugged in my initial condition. Does that make sense? Okay. So what follows is the rest of the process and points. ln of 1, what's that? 0. Yep. And 10 plus C? So -10 is equal to C. So I end up with natural log of absolute value of y equals 5/2 x squared minus 10. How many additional points have I earned since that last one? None. I have earned no additional points yet. There's still one to be had. I have not gotten it yet. What do I need to do to earn that final point?
Solve for y.
Solve for y. Okay, so I'm going to go e to both sides. On the right side, that leaves me with e to the 5/2 x squared minus 10. Make sure that that minus 10 remains up there in the exponent. On the left side, what's left over after I do that step? It's got to be the absolute value of y. It cannot just be a y. So we got to finally evaluate the absolute values and decide how this is going to work. Does anybody remember how this works? Has to do with the initial condition. So let me put it like this. The absolute value of y is either y or negative y, depending on if y is positive or negative, right? So if y is positive, then the absolute value of y is just y. But if y is a negative number, then the absolute value of y would be the opposite of that negative number. So how do we decide, I know, why or just the letter y? How do we decide whether it should be negative y or positive y as a result of the absolute values? Colin said something about the initial condition.
50%.
So the initial condition, now we want to be ultra careful about this. The initial condition y value is positive. We've got to go a little bit deeper. And I think where we want to go deeper is to this combination of steps over here. Ask yourself this question. The initial condition caused the absolute values to take a negative number and make it a positive number. In this case, the answer is no. So in other words, the initial condition did not cause a negative in the absolute values. Therefore, that means y is positive. And so the absolute value of y in this case would just be y. And we've got it.
So do you explain that?
No. You just got to make a decision. And if you think about this, Colin, like this over here is super dense on points. Like within those three-ish steps, you've earned 3 or 4 of the 4 or 5 points, right? You've earned all but one of the points. And in the following 1, 2, 3, 4-ish steps, the only thing you could do is earn one more point. Because all it is, it's just all algebra. And so you want to be careful. You could lose that final point by simply not making what needs to be negative, or vice versa. So you want to be careful with that, but it is like just algebra. Doesn't mean it's easy, but it's not the focus of the class. Question?
So where do you take that negative 10 and put it in front? Where do you break it into? Because it's like e to the...
Well, so you could do something like that. So like here's some variety of answers you could have. Like y equals, it could be y equals e to the 5/2 x squared times e to the negative 10th, which would then become y equals, hopefully we can see this, e to the 5/2 x squared over e to the 10th. Like that would be another form. I'd say either one of those two would be other forms you could have.
Okay.
Just by doing, exponent gymnastics.
Yeah.
I was never good.
Which may or may not be something you need to do. Good
Cool,
question.
thank you.
Yep, you bet. Anybody else?
So to get that, you have the positive y instead of like negative. You just plug in the y of -2 in, right? To make sure that.
Yeah, you're looking at what this does to the input of the absolute value.
Mm-hmm.
So in this case, the input of the absolute value is pretty simple, just a y. And
Yeah.
so because 1 is positive, y is positive.
Mm-hmm.
But you've got to be super careful because sometimes your input for your absolute value would be like y minus 5.
Yeah.
And so 1 minus 5 is definitely not positive.
Okay.
So that'd be where the absolute
So
value of y would actually be negative y.
Okay. So in that case, you take negative y and then you just.
Divide the negative over.
Sure.
Yep,
Cool.
exactly. Okay, well then I am curious to see how you all do with number 5. Please take a look at that. It is right here.
God bless.
There you go. Please try this one on your own or with your group. We'll see how it all goes. With this one, again, you got to show your separation of variables. When you show your separation of variables, guys, hey, listen up, please. It could look one of two ways. It could either look like this: dy over 3y equals dx over x, or it could be dy over y equals 3 dx over x. Right? Did you want to take the 3 over with the y, or or did you want to leave the 3 over there on the right side with the x? It could really go either way. I got to admit that I prefer this way, and here's my reasoning for preferring. Listen, here's my reasoning for that. Don't I know that in the end I'm going to have to solve for y?
Yeah.
So the less stuff I take with the y over there to the left side, the better. Because I know that whatever I take over there with it, I'm just going to have to take it back over later on, and I'd rather not have to do that. So I am going to use that one on the right. As long as we do all this stuff correctly, we should end up with equivalent answers. So there is, fellas, ladies, there's my first point. Separated my variables. Step 2, after I do my integrals, my antiderivatives, natural log absolute value of y equals 3 natural log absolute value of x plus c. At this point, I've probably earned maybe 2 additional points, 1 or 2, depending on how this is pointed out. I'm going to apply my initial condition now. To me, this makes sense. So this is y is e, which is already positive. When x is 1, again, already positive. And I put that sort of an equation. ln of e is 1. ln of 1 is 0. So I end up with c equals 1. So then my final steps would be to get the y by itself. So it'll be ln of absolute value of y equals 3 ln absolute value of x plus 1. If I want to get the y by itself, I need to e both sides. So I e this side, I e that side. That's going to give me absolute value of y equals e to this. And then my final decision would be, what do I do with the absolute values? If I think about my initial condition, e is positive, and the input is just a y, and so y is already positive, and so the absolute value of y will just be a y. So y equals e to the 3 ln absolute value of x plus 1. There are all sorts of different ways this could look as far as answer forms. Anybody get to some of those? So you could have this. We already know that x is positive, so you could have this. Right? You can move the 3 up. You could also have that. And what is e to the ln of x cubed? Crazy, huh? So any of these, those would all be fine as far as answers go. Okay, you guys have any questions?
If you did it the other way and you had your 3 like distributed, could you just leave the ln x plus 1 in parentheses and just leave the 3 distributed?
Sure.
Cool.
3 times parentheses ln of x plus 1/3 probably.
Yeah.
Yeah. Yeah, numerically it should end up being the same, but all the different forms, they could be whatever they're going to be. It's okay. All right, so I have a fun, I think this will be an interesting little exercise here. I want to show you guys this next question. It is the infamous landfill question, which used to be the lowest scoring averaged FRQ in the history of AP Calculus FRQs. It has now been surpassed only by the potato question as the lowest scoring average. Although, hey, listen up please. Listen up. Although I will say this question does still hold the record for highest percentage of non-answers. So in other words, when you're grading these things, if someone gets a 0 but they tried, that's considered a 0. But if someone either left it completely blank or wrote you a poem, that's considered lower than a 0 and it's a dash. Okay? So a dash means you didn't even really try, right? You left it blank or you just drew a picture of a flower and wrote a note to the reader or whatever. Over 50% of these questions had a dash. For this FRQ, this is back like 4 or 5 years ago. Oh, sure, there's plenty of 9s. There were thousands of 9s out of 9, but when you consider that there's like 400,000 tests, it's not a very high percentage. Yes, ma'am.
What's the funniest thing you've seen written on an AP test?
Usually it's like, just some sweet poem about sorry for this disaster, blah, 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 I don't want to ruin your day, or something. I mean, like, they're usually phrased pretty funnily. Usually there's a lot of swear words and stuff. I'm just like, come on. That has no mathematical meaning whatsoever. Just stop.
How did the escalator promise do?
It wasn't that bad. Not compared to the potato question of this one. There was a lot of complaining about it, but it was okay. Okay. Hey, so here's what I want you guys to do on the Twitter thing. Hey guys, we're all going to do one part of this. This will be a worthwhile exercise for you. Would you guys pick out whether it's A, B, or C, which of these questions has anything to do with finding the solution to a differential equation, like what we've been practicing? A, B, or C? C does, that's right. So here's what I want you guys to do for the moment. I want you guys to skip over A and B, and I want you guys to try to find C, okay? See if you can use all the information above. Skip A and B. I don't think you need them for C. Please just try C. Ready, set, go.
Do you still consider a non-answer if they answer like part of it, like A and
No. If they try A or B or C, it's considered an attempt.
Wow.
So literally, like, people left all of it blank, or just like wrote nonsense. Yeah.
Really well on
If all you did on C was like separate the variables, you got a point, right?
Yeah.
That's all you had to do, and apparently it just didn't happen. So I don't know. I think by that point they were so confused with all the W's and the T's, and it's a landfill, and I'm tired, and I don't know. It seemed like if you were really trying to score points here, you could at least snag one of these. Yeah. If I remember correctly, I think C was worth 5 points. So if you did handle C, at least you got 5 out of 9. So that was good. So again, just give you guys a couple minutes here to try this one. You can't.
There's no reason you should.
That's of course debatable, right? So let's just, can we do it for instance? Let's say you did distribute the. Oh, I don't want to. Let's not. I don't want that. It gets. Please don't make me do that.
I'm sorry.
So here's what I'm going to do. Here's what I've. Whether you did or didn't distribute the 125th, I'm seeing some major issues on the how do I deal with the W, right? So here would be my proposal. What I would do here right off the bat is I would divide both sides by W minus 300. So that's going to give me dW dt over W minus 300 equals 125th. Okay? And then what I would do is I would multiply both sides by dt. That would give me dW over W minus 300 is equal to 125th dt. That would be my inclination. This was a pretty big hurdle. I'll come back to that. Let me please show you what happens if you distribute. So if you distribute, you end up with dW dt equals 125th W minus 12. So you've definitely, hey guys, listen please. You've definitely got yourself in kind of a pickle here because that 125th is just a tad awkward. What you can't do is you can't move this W over here independently. You've got to move like the whole thing or not, right? So like if you did it this way, what you'd have to do is this essentially, dW over 125th W minus 12 equals 1 dt. And like I said, it's just a tad awkward with that 125th hanging out front there. I don't know. Do you see why that's a little awkward? So here is again, I'll go back to my proposal. This is what I would say would be best. I'm going to multiply both sides by dt and divide both sides by W minus 300, leaving me with this. The reason why I like this is because I'm keeping as much stuff over there with the t as I can. Keeping it as simple as possible on the left side. I don't want it to be complicated over there. Does that make sense? Okay. So then I'm going to integrate, find my antiderivatives. You guys get ln of absolute value w minus 300 equals 1/25 t plus c. My initial condition is w of 0 equals 1400, so that would be this. So clearly c is equal to natural log of 1100.
Is this a calculator? Or do we just leave it as that?
This was a no calculator, so you'd leave it as is. Finally, you'd get natural log of absolute value w minus 300 equals 1/25 t plus natural log of 1100. Kind of like the one we just did. How do I solve this?
E to the.
Yeah, e to both sides. E to this, e to that. I know for certain that w minus 300 is positive because my initial condition was w is 1400. So I would say that my final answer is w equals 300 plus e to the 1/25 t plus natural log of 1100, and all of its various forms. There are plenty of forms. So what do you think? Questions, concerns? Biggest concern I had was you need to put in the time and effort to correctly separate the variables. We were joking up here. It's not like if you just write them far apart, that's just good, right? You need to like algebraically correctly separate the variables in order to get that. So that's a huge bridge to cross. Yeah, go ahead, Jake.
Would I be wrong if I said it was 300 plus e to the 1/25 t times e to the ln of 1,100 and then brought the 1,100?
Oh, so this, you mean, so 300 plus 1100 e to that? That's a plus sign in there. Yeah, that's fine. I happen to agree with you. Jake, I like that. It's good. No, you don't have to go to any links to explain why. You just need to have it correct. Now, there will be times, I want to just tell you, there will be times when this, based on your initial condition, is negative. But then you would just like change the sign when you evaluate the absolute values. Yep, you don't have to write any notes or anything. You're welcome to it, but you don't have to. Other questions or concerns about any of that stuff?
Same thing with him, but like, can we just plug in our initial condition if it doesn't match up, then we just the signs?
Okay, well, we'll slow it. Plug in our initial condition if it doesn't match up.
Or if it doesn't like equal out, like if it's not 14 equals 1400, then like.
Yeah, categorically, that's wrong. Yeah, like you should be able to check against your initial condition. Something's wrong if it doesn't.
Okay, and like if it doesn't equal out, then I think it's like on the opposite side or opposite negative sign.
Oh, on the whole plus minus thing, that should reveal an issue. Yeah, for sure. Yeah, that should tell you whether you did that right or wrong. Yep. Yeah, because literally 0, 1400 should be on the graph of W. And if it's not, we got an issue. Hey, I want to give you guys a brief preview, and we're going to fill in a little bit of blanks here, if you guys would. Fast forward here to our final topic in this section, and this is brand new for everybody, so I thought I'd just lay a couple of minutes of groundwork here. We're going to look at logistic growth, and this is actually what we did, I believe, on day 1 of this year. Looked a little bit at logistic growth. Hey, guys, I want to get through this. Make sure you're paying attention. I know it's silly. So this is far more realistic for how a population, amongst other things, will grow. There will be a limiting factor called the carrying capacity. And down below is the differential equation. And I wanted to fill in these blanks, and we'll talk about the picture at the bottom. P is the population. I try to use letters that will help. P is population. It's how many people are there, how many bunnies are there, how many people who have heard the rumor or the lie, whatever. K is a constant. and M is what we call the carrying capacity. And this is that limiting factor. So in other words, if it was just us in this room doing an experiment, there's 20 of you, I think, and there's one of me, making for a total of 21. So if I said, hey, 29 of us are sick today, haven't I exceeded my carrying capacity? Couldn't there only be 21 of us that are sick? And so that's that limiting factor which would curb the growth of sickness, right? We could only have up to 21 of us sick. We couldn't have 29 of us sick, right? That's the carrying capacity. We'll talk about the little exponential growth stuff next time, or I guess Thursday technically. The whole thing with Katy Perry down there is just a mnemonic device to help you remember the solution to our differential equation. We'll get into that next time. It's simply mice minus Katy. It's pretty simple. And that's a very old picture, I realize. She doesn't have purple hair anymore. But I made these notes like 5 years ago. I'm not keeping up with the times. I'm sorry.
I don't think I've ever seen a picture.
There you go. All right. Apparently she's won a bunch of awards. All right. See you guys Wednesday morning for your test.
I don't think I've ever.